Let us now discuss question number 19 from the practice sheet. We have discussed up to 18th question. Now let us discuss the 19th one. Question number 19 says, prove that the opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center of the circle. Okay, so एक बार में read करने में समझ में नहीं आता. Okay, so let us read it again. It says, prove that the opposite sides of a quadrilateral. Okay, so it is talking about a quadrilateral. ये इतना हमें समझ में आता है. Okay, so prove that opposite sides of a quadrilateral circumscribing a circle. Okay, so there is a quadrilateral which circumscribes a circle. यहाँ तक क्वेश्चन हमें समझ में आता है. So first, let us try to draw the diagram for this much part. So question number 19. Let us draw the diagram. It says there is a quadrilateral. So first let us construct a quadrilateral, or first let us draw a circle. So this might look like a circle. Now after this circle, let us draw a quadrilateral which circumscribes this circle. So how will you draw a quadrilateral? We will draw 4 tangents. Okay, 4 tangents. So these are the 4 tangents. So this is our quadrilateral. Let us say A, B, C, D. So this is our quadrilateral. This quadrilateral circumscribes a circle. Okay. So this is the circle with center, let us say O. Let O is the center of the circle. Now it says that this quadrilateral circumscribes this circle. So circumscribe means circle is touching the edges of this quadrilateral. The circle is not intersecting the edges. Okay, circle ऐसा नहीं है कि इन edges के ऊपर से pass हो रहा है. This circle is just touching the sides of this quadrilateral. It means I can very comfortably say that if I talk about this AB edge, if AB side, this AB side is tangent to the circle. Okay, and let us say it is tangent at this point, and let us name these points as, let us say this is P. The point at which BC is tangent to the circle is, let us say, Q, and the point at which CD is tangent to the circle is, let us say, R, and the point at which AD is tangent to this circle is, let us say, S. So P, Q, R, S are the 4 points of contact. Okay, so this is what we have understood till now. Now further it says, prove that the opposite sides of a quadrilateral circumscribing a circle, this is a quadrilateral, subtend supplementary angles at the center of the circle. So which sides subtend supplementary angles? It says that the opposite sides of this quadrilateral subtend supplementary angles. So what are the opposite sides? We can see that side AB and side CD are opposite to each other. So I will say that AB and CD are opposite sides. So it says that this side subtends some angle at the center, this side also subtends some angle at the center, and the angles subtended by this opposite sides are supplementary, and supplementary means the sum of the angles is equal to 180 degrees. This is what we have to prove. So by joining this center O with point B and joining this center O with point A, we will going to have this angle, and similarly by joining this O point with C and this D point with C, this D point with O, you will going to have this angle. So we need to prove that the sum of these two angles is equal to 180 degrees, that is these two angles are supplementary. Okay, so let us try to prove this. First let us write the given conditions as we have done in each and every question of the circles. The given conditions are a quadrilateral ABCD, a circle with center O, okay, and the most important thing, P, Q, R, S are points of contact. Okay, so these four are the points of contact of this circle. Now this is what the given condition is. Now let us write to prove. What we need to prove? We need to prove that sum of opposite angles, sum of angles subtended by the opposite sides of this quadrilateral at the center of the circle are supplementary, or the angles are supplementary, or the sum of the angles is equal to 180 degrees. So in short, I can say that we need to prove angle AOB plus angle COD is equals to 180 degrees. This is the first thing that we need to prove. Since AB and CD are opposite sides, do we have another pair of opposite sides? Yes, AD and BC are also opposite sides. So I can say angle AOD plus angle BOC is equals to 180 degree. This is also what we have to prove. So these are the two conditions that need to be proved. Now, so we have written to prove. Now let us start the proof. How will you prove that the sum of these angles are equal to 180 degree? Let us understand this concept. What I can say is, you can very clearly see that P is a point of contact of this AB tangent and O is the center. So if I join this P point with this O point, this angle will be equal to 90 degrees, this angle, since OP is the radius and APB is the tangent to the circle. So this is the point of contact and OP is perpendicular to AB according to theorem 1. This is what you have learnt. Okay. Now similarly, if I join O with point Q, again you will have a perpendicular OQ perpendicular to BQC. Similarly, if you join R and O, again I can say RO is perpendicular to CRD, this line. Similarly, this OS is perpendicular to ASD. Okay. So after joining this, we will going to have, here we will have 1, 2, 3, 4, 5, 6, 7 and 8 angles. We will going to have 8 angles. Let us say this is angle 1, let us say this is angle 2, this is angle 3, this is angle 4, this is angle 5, this is angle 6, this is angle 7 and this is angle 8. So we have 8 angles at the center. Okay, these are the 8 points, 8 angles at the center. Now observe very carefully. If I talk about point A, what can you observe for the point A? You can see that from point A there are two tangents to the circle. One is APB and ASD. APB and ASD are two tangents to the circle from point A, and A is an external point. So try to remember the property, the theorem, the question that we have done previously, in which we have seen a circle. There is a circle and a point, an external point A, and from this point if I draw two tangents to the circle, this is how the two tangents will look like. Okay, and if I join if I draw perpendicular to these two tangents and I join this external point with center O, you will going to have that these two angles, this angle and this angle, are equal. You will going to have this property that these two angles are equal. How do we have proved this property? You can see this point A, from this point A I have two tangents AP and AS. Can I write AP is equals to AS? Why I can write AP is equals to AS? Because of theorem 2. By theorem 2 we have learned that AP is equals to AS, that is the tangents drawn from an external point to the circle are equal in length. Okay. Now after this AP is equals to AS, you can see that OS and OP are equal. I can write OS is equals to OP. Now why OS and OP are equal? Because both are radius of this circle. Similarly, third thing you can have is angle ASO is equals to angle APO. What is angle ASO and APO? Both the angles are 90 degrees because of theorem 1. Okay, each angle is 90 degree. Therefore, this angle and this angle both are 90 degree and both are equal. So what I can say is triangle ASO is congruent to triangle APO. Why ASO and APO are congruent? Because of RHS criteria. Because of RHS congruency criteria, right hypotenuse side. You can observe APO is this triangle and ASO is this triangle. In these two triangles we can see that these two angles are equal, so right angles we have. Then we have the second thing, this one, sorry, not by RHS, it is SAS, side angle side. We have the property side angle side. This is the angle 90 degree. This side is equal to this side. Okay, the right, these are the radius, and AS is equals to AP. So side angle side, side angle side. By this criteria I can say both the triangles are congruent, and since the triangles are congruent I can write angle 1 is equals to angle 8 by CPCT. This is what I can write, angle 1 and angle 8 are equal by CPCT criteria. So let us say this is our first equation. Now as we have considered point A, so we have angle 1 and angle 8 as equal. If we consider point B, what will happen if I consider point B? I can have two triangles from point B, BOP and BOQ, and the same way I have proved this ASO and APO as congruent, I can prove that BOP and BOQ are also congruent. So what I am going to write is similarly if you consider the two tangents drawn from point B, you will find that this OB is the line, this BP tangent is equal to BQ tangent. So you will have these two angles, angle 2 and angle 3. So what I am going to write is angle 2 is equals to angle 3. This will be our second equation. The same method what we have done is also applied at point B. We have applied at point A. Now we can write similarly for point B and similarly for point C also. From point C you can see there are two triangles, COQ and COR. So you can very easily, very comfortably prove COQ and COR as congruent triangles, and by that you will going to have angle 4 is equal to angle 5. This will be the third equation. You will going to have this as the third equation, angle 4 and angle 5 will be equal. Similarly, if you consider point D, again you will have DOS and DOR as two triangles. You can prove them congruent very easily, and you will going to have angle 6 equal to angle 7 equal by CPCT. Okay, so this is the condition that you will going to have. Now consider angle 1, 2, 3, 4, 5, 6, 7, 8. You can see that these 8 angles are constituting a circle. Okay, these 8 angles are constituting a circle. And what is the sum of angles that constitute a circle? The round the clock angle is total equals to 360 degrees. So what I can say is, I can say that angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 plus angle 7 plus angle 8 is equals to 360 degrees, and the reason for this 360 degree is that it constitutes a complete angle. Okay, the term used is complete angle. So these 8 angles constitute a complete angle. This is the condition that we will going to have. Now, what is angle AOB? Angle AOB is angle 1 plus angle 2. Okay, so I can write angle 1 and angle 2, sum of angle 1 and angle 2 as angle AOB. This is angle AOB. Okay, angle 1, this AOB. Now next is angle COD. What is angle COD? Angle COD is angle 5 plus angle 6. So in place of angle 5 and angle 6, I will write angle 3 as it is plus angle 4 as it is. Let us write it with another color, plus angle 5 plus angle 6 constitutes angle COD, and plus angle 7 plus angle 8 is equals to 360 degrees. Now observe very carefully, angle 3 and angle 4 are equal. Okay, this angle 3 and angle 4, sorry, not angle 2 and angle 3 are equal. You can see from the condition, from equation 2, angle 4 and angle 5 are equal. So in place of angle 3, I can write angle 2, and in place of angle 4, what is angle 4? This is angle 4. In place of angle 4, I can write angle 5. Okay, in place of angle 4, I can write angle 5. Then what is angle 7? Angle 7 is equal to angle 6. Which is angle 7? This is angle 7. These and these two angles are equal. So in place of angle 7, I can write angle 6, and in place of angle 8, this is angle 8. Angle 8 is equal to angle 1. So in place of angle 8, I can write angle 1. So plus angle COD is equals to 360 degrees, and this is angle AOB. Now observe it very carefully. Angle AOB plus, what is angle 2 plus 5? Angle 2, sorry, what is angle 1 plus angle 2? Angle 1 plus angle 2 is equal to angle AOB. So in place of angle 2 plus angle 1, I can write angle AOB plus angle COD as it is, plus in place of angle 5 and angle 6, sum of angle 5 and angle 6, it will be angle COD, this COD angle. So it will give you angle COD, and this is equals to 360 degrees. Now I can write 2 times of angle AOB plus angle COD is equals to 360 degrees. This will be AOB plus angle COD is equals to 180 degrees. This is what we need to prove. Okay, so what I have done, I have just used this equation and these 4 equations and just manipulated them in order to get angle AOB and angle COD. Now what you can do is again apply the similar approach to deduce angle AOD. What is angle AOD? AOD is AOD, that is 7 and 8. So try to convert angle 6 into angle 7, angle 1 into angle 8. And what is BOC? It is angle 3 plus 4. So try to convert angle 2 into angle 3 and angle 5 into angle 4, and you will get this condition. Okay, you will very easily get this condition, this second one, just by writing this, just by manipulating this equation. Okay, So this is how you need to prove this question, hence proved. Okay, so in this way you need to solve this question. This question is not a long question, it is just because I am explaining each and every word, that's why it took time to understand this question or to write this question. Okay, so this is how you need to solve question number 19. First note this, then we will continue.